Good morning, students. Today we will discuss about psychometric properties. First of all, what is the purpose of psychrometry? Because we are up to now we assumed air is a perfect gas. We applied ideal gas laws PV equal to nRT, the Boyle's law and Charles law. But in the realistic condition, air is not a perfect gas. Okay. Air contains moisture. We all know at monsoon time, morning time, the water droplets condensation we are visualize. Means air contains some moisture. So the moisture means water vapor. Water vapor is a pure substance. So air neither perfect gas nor pure substance. It is a combination of perfect gas and pure substance. The pure substance percentage in the air is very negligible amount, 0.001 kg per kg of air. That is secondary. But it contains perfect gas and pure substance. So to deal like this substance, separate science is required. That science only psychrometry. Once we introduced science, so how we are measuring the pressure means Dalton's laws of partial pressures we know. Pressure of dry air plus pressure of the water vapor. The summation, the average value will get the pressure of the atmospheric air, generally 1.0132 bar pressure atmospheric. So we are dealing separate science. Once we deal separate science, we want to discuss about the properties also. Science, some properties they are introducing for dealing this. First one, drivable temperature. Whenever we are moving to any industry for energy auditing or designing of refrigeration air conditioning system, one weather station, one word generally there. Once we visit that weather station, is just one wooden plank, clamps, two thermometers. That's all. One thermometer bulb is covered by the wet wick. That's all. With this, we can design any system. We can extract any psychometric property and we design the air conditioning system. So, first one is drivable temperature. Any industry, it's common drivable and wettable temperature. Easy to measure. After measurement of these two temperatures, by using these two properties, you can extract any property of psychometry and you can design the system. That much of important these two temperatures. First one is dry bulb temperature, means the measuring thermometer exposed surface, that is called bulb shape. That bulb is normal condition. At normal condition, at dry condition, the bulb in dry condition, we are measuring the temperature is called dry bulb temperature. The same bulb is covered by the wet wick and we are pouring water. Once air is moving with a certain velocity upon the wet wick, the air start absorbing the moisture. At one particular point, it will reach the saturation temperature. At particular point, it will reach the saturation condition. At that time, whatever the temperature we are measured, that temperature is called wet bulb temperature. Drop in temperature will occur. But wet bulb temperature, generally we can't measure immediately. We want to pour the water in wick, then air moving with a certain velocity, it want to be absorb the moisture and reach the saturation condition. Then after, only whatever the measurement of temperature we are measuring, that temperature is called wet bulb temperature. Wet bulb temperature always less than the dry bulb temperature. At saturation air we are measuring, then wet bulb temperature equal to dry bulb temperature. for designing of the cooling towers. For designing of the cooling towers, just we are measuring the difference between dry bulb and wet bulb. Based on that difference only, the size of cooling tower will decide. Okay. So based on the wet bulb depression, dry bulb temperature minus wet bulb. For saturated air, dry bulb temperature equal to wet bulb temperature. There we can't design the cooling tower. There is no use of the cooling tower if wet bulb depression is 0. Next property, specific humidity or humidity ratio. Just mass of water vapor present in the mass of air, total mass of air. That's all. Mass of water vapor present in the total mass of air. Generally, the range is 0.0001 to 0.030 kg of vapor by kg of air. That's all. 0.030 kg of vapor by kg of air. That's a maximum holding moisture in the kg of air. That's all. Very negligible amount. That's called specific humidity or humidity ratio. Next, dew point temperature. Once the air is holding the moisture, suppose in dry areas, maybe holding moisture 40%, something in coastal region 80%, 70%, like that, whatever. At we are start cooling, we are cooling the air. At one particular temperature, it is unable to hold the moisture. Whatever air contains moisture, it is unable to hold. The condensation of the moisture will start. The first droplet appears on the surface. That temperature is called dew point temperature. This dew point temperature specially depend upon the dry bulb temperature and wet bulb temperature. So, what is the necessity of dew point temperature? Means I want to remove the moisture, because for the human comfort, the relative humidity next to that property will come. Relative humidity 60% is required, but coastal region it is 90. I want to remove the moisture. Remove the moisture means you have to determine the dew point temperature. Because after below the temperature only the condensation of the water will take place. We can remove the, so we want to cool the air up to dew point temperature. Then after only you can remove the moisture. For that purpose, dew point temperature very much important for designing of the air conditioning system. Next, degree of saturation. Simple. Mass of water vapor present on the mass of total air divided by mass of water vapor present, or divided by mass of total air at saturation condition. At saturation condition, what is the mass of water vapor? I already mentioned 0.030 kg of vapor by kg of air. That is the saturation. General condition how much? Maybe 0.020 something. That ratio only degree of saturation. Next, relative humidity. It is like degree of saturation, but mass of water vapor present on volume of air, unit volume of the air, divided by the mass of water vapor present on unit volume of air at saturation condition. Why? Because while we are designing the air conditioning system, not volumetric flow rate, we are based on the volumetric flow rate. This much of volumetric flow rate required for the comfort. Meter cube per second something we are giving, 2100 meter cube per second for cinema theaters. That much of volume of flow rate is required. So based on the volume of flow rate only air conditioning systems we are designing. For that, relative humidity is the major driving force. So what is the relative humidity means? Mass of vapor present on the unit volume of the air divided by mass of vapor present on the unit volume of air at saturation condition. I think these are the major properties. Next, enthalpy we know. Enthalpy equal to internal energy plus flow work. Enthalpy of air, generally how we are determining is enthalpy of dry air plus enthalpy of water vapor. Simple equation I shown. The representation of the psychrometric chart. You see, direct chart we can open. In this is the 100% saturation line. This curve is called 100% saturation line. Means relative humidity is 100. That's why relative humidity is 100. Next, relative humidity 90, relative humidity 80, 70, 60, 50, 40, 30, 20, 10. These are the relative humidity lines. Next, in y-axis you can see this is the specific humidity or humidity ratio. The value starting from 0.000 and end 0.030 kg of vapor by kg of air. This x-axis is dry bulb temperature. Next, the vertical lines are dry bulb temperatures. The inclined lines are wet bulb lines. The dry bulb temperature is varying from -10 to 60 degrees. Wet bulb temperature -10 to 30 degrees. 32 degrees maximum. -10 to 32 degrees is the wet bulb temperature range. Next, one more inclined lines are there, specific volume lines. These wet bulb lines we are extending up to enthalpy where it is intersecting. At particular junction point we can determine the enthalpy. This is the enthalpy line. Just wet bulb lines we are extending up to enthalpy where it is intersecting. That is the enthalpy of the air at a particular point. Next, dew point temperature. I already mentioned it is important. Suppose this is the intersection point, dry bulb temperature and relative humidity. Then you move horizontally upon the saturation curve. You move horizontally upon the saturation curve. Then you see the dry bulb temperature, whatever the dry bulb temperature is there, 20. Here, suppose here this is the 35 degrees and 40 relative humidity. 35 and 40 relative humidity. What is the dew point temperature means? Just you move horizontally upon the saturation curve, you are getting 20 dew point temperature. So 20 degrees, you want to cool the air up to 20 degrees. Then only the water condensation will take place. Means we can dehumidify the air. We can remove the moisture from the air up to cooling 20 degrees. Your human comfort not 20 degrees, 26. Even though your comfort is 26, first cool the air up to 20, then remove the moisture. Then after you expose to the open atmosphere. Without insulation duct, the air is flowing means automatically it will gain the heat and 26 degrees temperature. You can issue and you can supply the for air conditioning purpose. Okay, this is the brief explanation of the psychrometric chart. All properties we represented. This is the specific volume lines, dry bulb temperature, wet bulb temperature extended, we will get the enthalpies, and one more inclination lines are specific volume lines. These are the relative humidity lines. Okay, next class we will discuss about air conditioning process. Thank you very much.